Cool. Metering light and knowing what exposure to expect is a big part of the job. So today, we're going to look at one of the laws of physics that's all about our business. On today's call sheet, the inverse square law. The inverse square law states that the intensity equals 1 over a distance unit squared. It calculates how much light falls on a specific spot at any given distance from a starting measurement position, right? So let's say our distance is about 3 feet, right? If we measure our intensity, we get 40-foot candles. Now, if we double that distance to about 6 feet, our intensity would drop about 1/2 squared. In other words, doubling the distance gives about 1/4 the intensity, or in this case, 10-foot candles. It works every time. Well, almost. Many gaffers and DPs have observed that the inverse square law does not work on large sources, that the readings are unreliable. And to a certain extent, they are right. But the discrepancy lies in the omission of a key element, which we will explore today. Light travels in all directions from this light bulb. Obvious enough. To make it directional, we either redirect the light to one path, or in this case, we block all the light except for a single side. Now, all the photons that were just flying away freely can only come out of this hole. This is our directional light. And as you can see, it's relatively a small source. In fact, the diameter is 6 inches. So let's take some readings. At 2 inches, I get 300-foot candles. At 4 inches, I get 150-foot candles. And at 6 inches, I get 120. If I meter at every single point, I get these results. As you can see, the relationship from 2 to 4 inches does not conform to the inverse square law. However, if we look closely, the number of foot candles at 6 inches is about 4 times that at 12 inches. And at 24 inches, it's 16 times greater, and so on. What's going on? If I'm standing close to a huge source, like this 848, here I am about 8 inches away from my light source. But not really. I'm 8 inches away from this tube, but I'm a couple feet away from the top and bottom tubes. So, few photons from there are hitting me. Thus, the intensity is less from those parts of the light. But as I back away, I diminish the difference between the closest point in the middle and the furthest points on the edge. At what point does this become negligible? A good rule of thumb is the diameter of your source's emitting surface. So if you recall the 6-inch circle of our table light, you have to be 6 inches away to start calculating fall off using inverse square law. If your source is a single 8-foot rainbow tube, then you have to be about 8 feet away. If your source is an 848, you have to be about 11 feet, 4 inches away. Now, it's important to remember that you can set your distance unit to any scale you want, so long as the minimum distance is equal to or greater than the diameter of your source. For example, if you're shooting a night exterior with an 848 50 feet up in a condor, then you might be better off making your starting calculation distance unit 25 feet or 50 feet. That way, you can keep your calculations on the simpler side. Conversely, if you're doing a tabletop shoot, you'll want to have your units as small as possible, as you're no doubt in tight quarters, and the scale is so much smaller. What this also suggests is that linear lighting can often act as a substitute for large source lighting. If an 8-foot tube spans the diagonal of a 6x6 bounce, then we can often think of an 8-foot tube as a 6x6 bounce with much less space. We now consider linear light as large, soft source lighting in one dimension, with all its benefits of beautifully wrapping the subject with an even distribution of soft light. It's so versatile, the slim form factor opens up the possibilities of placement. Your broad soft source can now slip between your actors, or tuck up into the corner of a room, or discreetly stand next to a camera in your tiny location. But what about other applications? How can we use the inverse square law to help plan and budget your production? Well, knowing exactly how many foot candles will fall in any given region of your set before you've even stepped on stage could be really useful in planning your rig, choosing your fixtures, and knowing what exposure leeway you'll have. And if we're rigging for a volume, knowing the range of foot candles is essential for matching the exposure of the LED wall. This advanced knowledge helps predict how many fixtures you'll need to make the lighting rig work for your shoot, reducing tweaking on the day. So if it's a conventional or a virtual production, knowing how to predict your light's output will always be one of the best tools to have in your back pocket. Thanks for tuning into the science. We'll see you at Crafty.
Remember that you're happy to be here, Tim.